Hello everybody. Today I'm going to do a completely new lesson on regulation of gene expression. You haven't seen anything like this before, so this is chapter 18 if you'd like to look at it in your text. It's about a concept called an operon. So this is only in prokaryotic organisms. Bacteria normally get what they need from their environment. However, you probably realize that they're so prolific and they've been around for billions of years. So they have the ability that if their needs aren't met from the environment, they can actually create what they need. And this happens at the transcription level through messenger RNA. So the basic model, and it's called the TRP operon, was discovered in 1961 by Jacob and Monod. They actually figured out how bacteria can synthesize tryptophan. Well, if you remember, that's one of the essential amino acids. Those kind of things work on feedback mechanisms. Remember, we did feedback way back in the first chapter. So basically, if they have what they need, then this gene is off. And if the environment doesn't provide them with what they need, then the gene is turned on. So it's a negative feedback mechanism. Okay, so what it is basically the operon is a series of 5 genes. It only takes 5 amino acids to create tryptophan. And basically it can make as many or as few as the tryptophan molecules as it needs. And it makes 5 separate proteins depending on where the stop codons are. And I'll show you that in just a minute. So all of these genes are clustered together on one chromosome. So they studied E. coli to figure this out in the 1960s. So the advantage of this is basically there's a single on-off switch that can control the whole gene production. It's controlled coordinately, all done at once. And then the switch is called the operator. And then where they get the term operon from, it's the operator plus the promoter plus the 5 genes. So here is a diagram of this, and let's start over here. So obviously tryptophan A through E, these are the genes of the operon. So these are the 5 genes that actually make the 5 proteins that are needed to make tryptophan. Okay, here is the operator, and here is the enzyme, right? Remember, polymerase is an enzyme that creates this. So when this polymerase is attached to the promoter site, then the genes can be created. So obviously, if we stop the polymerase from binding to the promoter, then these genes can't be transcribed. So that's how the TRP operon works. It's normally off, but it can be turned on. Okay? All right, so here is the actual repressor protein that blocks this from going through here. Okay, so when this is not attached to this, it is creating tryptophan. When this is attached, tryptophan is not being made, which means the bacteria is getting what it needs from the environment. Okay, so if it can be turned on, that means it can also be turned off. So that's what a repressor does. Okay, it binds to the operator and blocks the polymerase from attaching, which prevents transcription. And remember, since it is a protein, it is definitely shape specific. Okay, so here's tryptophan. See how it fits nicely into this repressor. So you can imagine that if there's plenty of tryptophan in the environment, then this repressor is going to be blocked, and it's going to change its shape, and it cannot make RNA. Okay, but if the tryptophan is absent from the environment, then this can attach, and then tryptophan will be made. So again, it's that feedback mechanism. Okay, so sometimes there are co-repressors, just like we talked about coenzymes in chapter 8. So it's a molecule that operates with the protein to switch an operon off, and then an inducer. Think about like if you know someone who had to be induced into labor, that means they made it happen. So an inducer inactivates the repressor, which makes the transcription happen. Okay, so I'm going to show you some examples with some online activities of 2 kinds of operons. So the one that I just showed you about, the tryptophan operon, is inducible. So what that means is it's normally off, but it can be turned on if the environment doesn't give the bacteria what it needs. That's inducible. Then I'm going to show you another one, which is called the lac operon. It is repressible, which means it stays on all the time until it needs to be turned off when enough of the protein is present. That's called the lac operon, and lac stands for lactose. So if there's enough lactose in the environment that needs to be digested, then we're going to turn it off. If there's not enough, then we're going to turn it on. So what I'd like for y'all to do is do the 2 activities that are attached with this video, the one on the TRP operon, and I'm going to show you this video also, and then the one on the lac operon, so you can see the difference between inducible and repressible. And then it also gives you like a little quiz to do at the end, and then it gives you the opportunity to email it to me. Just do that. I'm not going to put that grade in the grade book or anything. It's just for you to practice. If you have any questions, please let me know. I think the last thing that we need to do is like genetic technology, like what we can do with DNA fingerprinting and plasmids and things like that. And then we should be able to start reviewing. So email me if you have any questions. I'm always here for you.